Okay, folks, we're going to move into 5.2 on systems of linear equations in two variables. This is just a quick review. 5.1 was the graphing method. We now go to 5.2. 5.2 is an algebraic method. It's called the substitution method. One of the reasons why it's called that by the name of substitution is because we're going to be taking an expression from one of the equations and we're going to substitute it in place of either x or y in the other equation. So let's kind of give you the background of how the substitution method goes. First thing, when we're using the substitution method, our objective is to get a variable isolated on one side of a given equation. Now we know when we're dealing with a system, we're dealing with two linear equations that contain the same variables. In order to use the concept of substitution, we need to take one of the equations from the system and we need to get a variable, either an x or a y, completely isolated or completely alone on one side of the equation. If we look at system number one, it's going to be the first one that we do. Notice the second equation already is giving us an equation where the variable x is alone on one side. That's why all the rest of the numbers were in black, but the x is in blue, because equation number 2 has already been solved for one of the variables. We want to get the variable isolated on one side of the equation. On system number 1, the variable x is already isolated on one side. The other consideration that we want to speak to in terms of substitution is when we're looking at a system where one of the equations has a variable that can be easily isolated. Now on system number 2, forget about the second equation. But if we look at the first equation, it says x minus 2 is equal to 2y. Notice that the variable x in the top equation has a coefficient of 1. Now that variable x is not alone yet, but we can get it alone by simply taking that negative 2 and moving it over to the other side. And when it moves over to the other side, then we'll have a situation to where the x is alone on one side, just like the x was already alone on one side here. In order to use the substitution method, one of the equations of the system must be solved for one of the letters, either x or y. Either the x has got to get alone or the y has got to get alone. On system number 4, notice that the coefficient of y for the top equation is a negative 1. It would be very easy to take the top equation and get this solved for y by just simply moving the 5x over to the other side and then dealing with a very basic step then to get that variable y alone on one side. That is the target thing that we want to make sure that we do going into substitution. So we're going to start with number 1 and we're going to show you kind of how it goes. I've got it up here and we're going to do the work right in here, but I'm just coming back to him for just one more moment. Here's the idea. The second equation says that x is equal to y minus 3. here's where it gets the name substitution. We're going to take the expression y minus 3, which is equal to x. We're going to take that y minus 3, and we're going to substitute it in place of x in the other equation. Why can we do that? Because that's x, and it says down here in the second equation that x is equal to him, y minus 3. That means the same thing as x. So we're going to substitute that y minus 3 in place of x there, and then we're going to solve that resulting equation, and we'll be on our way to using the substitution method. Let me just make one clear statement before we do number 1. The substitution method works very nicely when one of the equations is already solved for one of the letters, or when one of the equations can be easily solved for one of the letters. What makes an equation easy to solve for one of the letters? On system number 2, the reason why we should choose x to solve for in problem number 2 is because the coefficient of x is 1. And because it's 1, it can be easily solved for x by just moving the negative 2 over to the other side. You would not want to do this on number 2. You would not want to solve the second equation for x because its coefficient isn't positive or negative 1. You wouldn't want to solve the second equation for y because its coefficient is not 1 or negative 1. You want to pick an equation that has a variable term with a coefficient of either positive or negative 1. So we're going to begin the process, and here's how it goes. Problem number 1. The variable x is already alone. We've already mentioned that x is equal to this binomial of y minus 3. We're going to take this y minus 3, and we're going to substitute it in place of x in this top equation. Now here's what I would ask you to do when you're doing this. Take this equation right here that is going to receive this y minus 3 and bring it down a ways. Give yourself some room right here. Bring down that top equation. 4x plus 9y is equal to 1. And now we're going to begin to substitute. Bring down the coefficient of 4, make a house. Inside that house, where x is supposedly going to go, we're going to take this expression that x is equal to the y minus 3, and we're going to substitute it in place of that x. Right there. And then copy the rest of this equation. Now look at this brand new equation that we've got. It's an equation that only contains the variable y. So let's just solve this equation for y. Got to distribute. 4y minus 12 positive 9y is equal to 1. Combine like terms. 4y and 9y, 13y, negative 12 is equal to 1. Positive 12, positive 12, 13y is equal to 13 over 13 on both, and we get a pretty little value for y, which is 1. Now keep in mind, remember the solution to a system is an ordered pair. We have our y value of our ordered pair. So clearly come up in an isolated spot, make the structure of an ordered pair, put 1 in the y position, and now we have to find the value of x. And the reason why I left some space up here is because to find the value of x, there's no better equation to use than this one right here that we used to substitute. This tells us how to find the value of x. It says take your value of y and take 3 away from it. Well, we've got our value of y. So we're going to substitute this 1 we're going to back substitute this 1 in place of y. And we'll get x is equal to 1 minus 3, and that would give us x is equal to negative 2. Put that negative 2 there, and we have solved the system by substitution. Now that is the elementary one. Why was it nice? Because the second equation was already solved for a single variable. Let's go to the second one, and when we go to the second one, we'll have to do a little bit more work, but not much. Number 2, x minus 2 is equal to 2y. That's equation 1. 4x minus 5y is equal to a negative 4, and that's equation number 2. Now notice, neither one of the equations has a variable that's completely alone on one side. But one of the equations has a variable whose coefficient is either 1 or negative 1. That's the key. You want to find a variable term that has a coefficient of 1 or negative 1. It's not him. It's not him. It's not him, but it is him. So we're going to take equation number 1, and we're going to solve this for x. And once we get it solved for x, then we'll be able to substitute. So here is what I would do in this case. We're not touching him at all yet. This second equation is going to receive the substitution in a moment. It's the top equation that we need to get solved for x. So let's take that top equation and let's move it down a ways. Let's just kind of move it down a ways. Give yourself some room. I'm going to bring down that x minus 2. And that's equal to 2y. We're going to solve this equation for x so that we can substitute then. To solve it for x, got to get rid of that negative 2 by going opposite. Positive 2 on both. We'll get x is equal to, now this is commutative. You can either write down 2y plus 2 or you can write 2 plus 2y. It doesn't matter. I'm going to go from top to bottom. 2y plus 2. We have now taken equation 1 and we have solved it for one of the variables. He's alone now. X is equal to 2y plus 2. Why the room? Because we're going to now substitute into this second equation. X is equal to 2y plus 2. In place of x here, we're going to put 2y plus 2. Sit down. Make a house. In place of x, 2y plus 2. Bring down the rest. Negative 5y, negative 4. Look at the equation. It only contains the variable y. Solve the equation for y, and we'll have our y value. Distribute 8y, positive 8. Negative 5y is equal to negative 4. Combine like terms. Don't change any signs here. They're on the same side. Just add the positive 8 with the negative 5. 3y plus 8 is equal to negative 4. Negative 8 on both sides. 3y is equal to negative 12. Over 3, y is equal to negative 4. Find a spot. Put that negative 4 in the y slot. And now to find the value of x, go back to the equation that was already solved for x. X is equal to 2y plus 2. To find x, we have to know the value of y. We know it. X is equal to 2 times negative 4 plus 2. That's equal to negative 8 plus 2. That will give us negative 6. Put the negative 6 in the x spot. Done. What must be true when we use substitution? There must be a variable term somewhere in the system that has a coefficient of 1 or negative 1. I would never give you a system that would not have a coefficient of 1 or negative 1 and ask you to use substitution. I wouldn't give you any other type. If we're going to use substitution, the coefficient of one of the variables of either of the equations has got to have a coefficient of 1 or negative 1. Now, let's not get frustrated at all on number 3 just because maybe you're looking at fractions right here, because we're going to get rid of them. X plus a half y is equal to a half. That's number 1. 1/6 x minus 1/3 y is equal to 4/3, and that's number 2. Now, if we take a gander at that system right now, this is very true. As it stands right now, this is the only variable that has a coefficient of either 1 or negative 1. But we would not want to take equation number 1 and solve this for x when it's cluttered with all of these fractions. So we're going to do a redo on equation number 1. We're going to do a rewrite of equation number 1 so it doesn't have any fractions. And that's LCD. We're going to clear the fractions on number 1, and we're going to clear all the fractions on number 2, so we have a system that just has integer coefficients. We're going to change number 1, so I'm going to give it a new number. Instead of it being called number 1, we're going to call it, when it gets fixed up, we're going to call it number 3. And when we fix up number 2, we're going to call it number 4. Now let's fix up number 1. The denominator is 2. The denominator is 2. The LCD, 2. We're going to write it in 3 different locations. Tuck, tuck. We're going to write it twice over here. There for him. And maybe right about here for this one. And definitely over here. Now let's get this one ready as well so we can roll right into it. Number 2, 6. 3, 3. LCD has got to be at least as big as 6, and he works. We're going to write it a total of 3 times. Tuck, tuck, tuck. Put the 6 for him. You can stick another one if you so choose, maybe right about there. Definitely over here. All right, let's go. Go back to number 1. Let's distribute. 2 times x. Plus. Cross cancel, folks. 1. 1. 1y. 1 times 1y. 1y is equal to, cancel. 1. Number 2 will become number 4. Cancel. 1 times 1x, x. Negative. The 3 and the 6 will cancel. 3 divides into itself once, into 6 twice. 2 times a negative 1y. 2 times a negative 1y. A negative 2y. Cancel. 1, 2, 8. Don't care any longer about 1 and 2. Here's the brand new system. I'll look at it and find an equation that has a variable term with a coefficient of either 1 or negative 1. No. No. Yes. Yes. You have a choice. We can either take equation number 4 and solve it for x, or we can take equation number 3 and solve it for y. It doesn't matter. What does matter is, no matter which equation you pick, you want to solve it for the variable term that has a coefficient of 1 or -1, not them. Either of those would be fine. So I think I'm going to do this. Let this bottom equation stay right there, and let that bottom equation receive the eventual substitution. Let's take equation number 3 and let's bring it down a ways. Number 3. And let's solve this number 3 for y. -2x. -2x. Y is equal to, you can either write 1 minus 2x or -2x plus 1. It doesn't matter. I'll go bottom to top. It doesn't matter. Now we've got this equation solved for y. Y is equal to a -2x plus 1. Now we're going to take that -2x plus 1 and we're going to substitute it in place of y in this bottom equation. Remember, it was number 3 that we decided to bring down and solve for y. And we did. Now we're going to substitute -2x plus 1 in place of y in equation number 4. Down. Down. Make a house. In place of y, -2x plus 1. Copy the rest. Now let's solve this equation for x and we'll get our x value. Down. He's the distributor. Negative times negative. Positive. Negative times positive. Combine like terms. 5x -2 is equal to 8. +2, +2. 5x is equal to 10. Over 5 on both, x is equal to 2. Get a house. Put that 2 in the x spot. And now we have to find y. And he's the equation that we're going to use to get our value of y, because it says how to get y. Multiply -2 by your value of x, and then add 1. -2 times 2 plus 1, -4 plus 1, y is -3. Done. Don't you get bothered by those. Don't you let those fractions get the better of you. We defeat it. We get rid of them. We're going to get rid of those fractions. They're nothing to worry about. We get rid of them. Now let's finish up that fourth one. Now the fourth one, kind of a heads up on the fourth one. It's going to be unique. It's going to be one of the special kind of cases that we wanted to share. Here it is. 5x minus y is equal to 6. That's number 1. -10x plus 2y is equal to a -12, and that's number 2. We don't have any fractions to worry about. We don't have any decimals to worry about. Find a variable term that has a coefficient of either 1 or -1. That is the one that we want. No siree. Nada. Nada. Yes. Yes. Take this equation number 1, bring it down. This equation is going to receive the substitution that this equation is going to give us. Bring down number 1. 5x minus y is equal to 6. Get rid of that 5x. -5x, -5x. When you bring down this term, I believe it's best to show its coefficient. Negative 1y is equal to a negative 5x plus 6, or is equal to 6 minus 5x, it doesn't matter. Divide both sides by negative 1. There. Here. Here. Y is equal, negative divided by negative, a positive 5x. Positive divided by negative, a negative 6. We have our substitution expression. Y is equal to 5x minus 6. 5x minus 6, we'll put it in place of y in this equation number 2, right there. Down. Down. House. 5x minus 6. Bring down the rest. Copy the rest. Solve the equation for x. And you'll notice something unusual. We saw it in chapter 3. We're now going to see it in chapter 5. Negative 10x. Distribute. Positive 10x. Negative 12 is equal to negative 12. Goodbye. We lost our x's. That's unusual. That's going to lead to an unusual answer. We lost our x's. They cancel out. Look at the numerical statement that we're left with. They go, and we're left with this. Now let me take you back to chapter 3. When we were solving an equation in one variable, and the variable terms canceled out, and we ended up with a numerical statement that was true. This is true. Negative 12 equals negative 12. Rule. When the variable terms get canceled out, and you end up with a numerical statement that is true, that indicates that this system has an infinite number of solutions. An infinite number of ordered pair solutions. We don't know what all of them are, but there are an infinite number of them. And you just simply write as your answer. I'll put it in a box. Infinite solutions. Now that's not going to be a common occurrence, but that's exactly what this one is. That's substitution. Now we're going to get some things set up, and as long as I got some light in this room, we're going to take care of 5-3 as well. But for right now, we'll say adios, and we'll get up with you in a moment.